All right, here we are again. We are going to now take a look at covalent and ionic bonds to determine if they are polar or nonpolar. One of the things that we can make mention of first, and go ahead and get that out of the way, we know that it is going to be an ionic bond if it contains a metal and a nonmetal. But as you see here, we talk about electronegativity and the differences between polar and nonpolar. Ionic also has that. So that's going to be anything with an electronegativity difference. So we're just going to call that ED at this point. That's going to be anything greater than 2.0. Okay, anything greater than 2.0 and electronegativity difference is going to be an ionic bond. So let's talk about the covalent bond, the bond that happens between two nonmetals. So we talk about polar being unequally shared within those compounds. So here we would have, for instance, HCl. HCl is going to be something that does not equally share those electrons between those two. But we're going to also talk about this in the differences of electronegativity. So if we were to pull out the electronegativity chart provided in your book or by your professor, you would be able to then determine your differences in electronegativity. So let's take a look first at HCl. And we're going to see exactly how this electronegativity chart is going to be able to help us to determine what our compounds are. So take a moment, locate that in your notes or in your book. So let's see, when we talk about difference in algebra, what mathematical operation do we have to perform to receive a difference? In order to receive a difference, it's going to be a subtraction operation. Okay? So we're going to look and we're going to see within our chart that hydrogen has an electronegativity of 2.1. Okay? Then we take a look also on the chart and we see that chlorine comes in at a 3.0. Simply stating, we're going to take the difference of chlorine, the 3.0, and we're going to subtract the electronegativity of hydrogen. This is going to give us a difference of 0.9. Well, according to the definition of electronegativity, when dealing with the difference of them, anything that falls within the ranges of 0.5 to 2.0 is going to be a polar bond. Okay? So let's take a look here at a non-polar covalent bond. That's going to be where our atoms or electrons are equally shared. So let's take a look at, for instance, Cl2. So we already know from our previous problem that Cl is going to be 3.0. So let's see what happens if we take the difference of the elements in our compound. So 3.0 minus 3.0 is going to yield us a difference of 0. Okay, so anything that is non-polar, okay, is going to be less, okay? This is going to be the most it can be, so it's going to be less than 0.5. So anything less than 0.5 is going to be a non-polar covalent bond according to electronegativity. Okay, so let's take a look at what happens if we were to get the difference of a metal and a non-metal just to see what happens with ionic bonds. So we have sodium, okay, and we have chlorine. Well, we've already been working with chlorine, filling what we know. Chlorine, we know, comes in with an electronegativity of 3. And if we take a look at whatever electronegativity chart is provided to you, you see that sodium has a 0.9. Okay? So what happens when we take the difference of these? So we have 3.0 minus 0.9 is going to yield us a difference of 2.1. Well, as we see, that definitely goes with the rule that we have that the electronegativity difference in an ionic compound is going to be greater than 2. And 2.1 is definitely greater than 2. All right. Thank you for watching and be on the lookout for more videos.